Hatsios. Δεν πειράζει, άστο. Hello there, I'm Thomas Hatsios, German American pilot flying the Boeing 787-900 tonight's flight from Zurich International Airport. We're going to be overflying Zurich, Switzerland, Germany, then coming back to Zurich International Airport, runway 1449, Lszh localizer, landing around in the cockpit for the pre-takeoff preparation of the quality wings, Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900 aircraft. I'm going to start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel. The ground speed is already above the ground level. The barometric altitude of the outside atmosphere. The target altitude is selected from the autopilot flight director system panel. The barometric pressure of the outside atmosphere. The rate of climb descent of the aircraft in 10,000 feet per minute. All the stiffness of the trigonometric angles in degrees it can climb and descend. We have also the artificial horizon with the altitude indicator, the pitch ladder in degrees, and the bank angle in degrees. The Lszh localizer, we have the horizontal localizer and vertical glide slope. You can receive the onboard antennas, receiver antennas. We have, and they can receive from the airport and runway we use for takeoff and for landing. The runway threshold antennas that transmit the Lszh localizer, the instrument landing system. Radio frequency that help the aircraft align with the runway heading. So we're gonna use the magnetic north pole heading of runway 136 degrees of runway 14 in Lszh Zurich, Switzerland Airport. You're gonna see that displayed in the primary flight display. So we have the Lszh localizer, the horizontal localizer, vertical glide slope. The flight director crossbars for manual guidance of the aircraft and the autopilot crossbars for the automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies in the flight mode and zero with the autopilot and the autothrottle. Later on vertical navigation modes. You can see also we have the HSI, the horizontal situation indicator down here in the primary flight display. So I will show you all the instruments, navigation display, ACAS and navigation system display. So we have the navigation display that displays the magnetic heading and track, the magnetic north pole and true north pole, the geographic north pole and magnetic variation depending on where we are in the world. We have the GPS coordinates of the aircraft, the GPS position. You can see the terrain and weather reflection from the weather radar with red, green and yellow color indication. So you can see also as you fly how far above you are from the ground. In the vertical, in the VSD, in the vertical deviation display. So you can see also the, as I told you, the terrain and weather reflections with red, green and yellow color, and also with blue for the lakes and the rivers and the sea. So you can see also the airports. The airport we are located right now, the Zurich International Airport, Lszh in Switzerland. We have the airport 4-digit 4-letter account name displayed, and you can see also the runway we're gonna use for takeoff and for landing. I'm gonna select using the flight management computer the runways for takeoff and for landing in the airport that we are located, and we're gonna create a flight plan or a flight path or a route for this aircraft flight. So you will see the route displayed, the flight plan display in the navigation display with a purple magenta line, and also it has legs with the intercept the waypoints we have to cross through step one by one as we climb cruise, descent, approach, and landing. So this is gonna help us also connect the autopilot with the LNAV and the VNAV navigation modes. We have too many modes in the autopilot. The director system panel of the Boeing 787 900Z aircraft, as you can see, is the identical with the original aircraft. Modes and functions of the cockpit, also the flight. You're gonna see the flight controls, the engines, the thrust. So I'm gonna show you a complete flight from takeoff, climb, cruise, descent, approach, and landing. A complete flight with the jet aircraft, the Boeing 787-900. You can see here the navigation display. You can see the airports, as I told you. Also, we have the nav aids displayed, the navigation aids, the workstation, the ADFs, the NDBs. Also the waypoints, which are horizontal and vertical navigation fixes. Those we have to cross through. We're gonna select some using the flight management computer and gonna cross them during the flight. So you have we have the waypoints, as I told you. We have also other aircraft that fly around us, also displayed in the navigation display. Using the transporter, the ADSB and ADC transmitter receiver that transmits our frequency to other aircraft and the air traffic control, and receives from other aircraft their frequency, and this way it can make calculations using the computer and display the position of the other aircraft in the navigation display, the distance in nautical miles, in the distance ring. You can see how far they are located, the distance, whether they climb or descend with respect to your aircraft as you fly. Also, you can calculate the velocity between your aircraft, the velocity difference and the velocity closing in between your aircraft and other aircraft using the radio frequency receiver and transmitters. So you can calculate if we have an incoming collision with another aircraft, it will give us a warning. And this is the TCAS system, the traffic collision advisory system. You can see the warnings in the navigation display and the primary flight display, and we're gonna make an avoidance maneuver if we are in flight. For instance, you can see also in the ground over here in the airport you are located other aircraft. So we have also, as I told you, we're gonna use the flight management computer. I'm gonna start showing you the displays, the panels over here, the flight controls. So I'm gonna show you the flight controls, also how to use the yoke of the Boeing 787. I have the side stick here to make it climb, descend the aircraft, also make bang rolls left and bang rolls in the air, bang rolls to the right, the rudder pedals also. So we have many flight controls, each one has its own input from surface, and I use the side stick that is made for the Airbus, no problem for that. We have the same effect in the flight controls and in flight conditions, also the thrust levers. Over here you can see we have mapped the function of the thrust levers. We can move the thrust forward and aft to increase and decrease the engine thrust and power setting over here, which generates the propulsion from the engines, from the jet engines that we have. So I'm gonna show you all the systems of the cockpit, the flight controls. Also we have the horizontal trim stabilizer over here. I'm gonna talk to you about how to use the horizontal trim of the Boeing aircraft. You can trim up, as you can see, using this switch, and trim down. This is trim up the nose of the aircraft as you flying, and trim down because you trim up and down the horizontal tail surface of the elevator. Trim left and right, as you can see. So you can see the display over here, elevator. It will display something right now. The indication elevator trim, left click down, right click up, as you can see. So this is the elevator surface. Trim up and trim down. We have also here, so I'm gonna start showing you the flight controls. So we have the elevator trim cutoff switch. We have a failure of the flight controls, so of the elevator left and right auto trim function, because we have also the auto trim. This is a fly-by-wire aircraft. This is for all Boeing aircraft: 737, 747, 757, 767, 777, and 787. You open up this guarded switch from normal to cutoff, and you disconnect the auto trim function from the autopilot, the auto throttle. Over here you can see later the auto trim function, because this is a fly-by-wire aircraft. This has also its auto trim from the flight control computers inside. You can use also the manual trim input to trim the horizontal tail of the aircraft in flight and balance it as you fly, using the thrust also from the engines and its attitude. You can change the attitude using the yoke, for instance, for climb, descent, the elevator, and the rudder pedals and the ailerons and spoilers. So you're gonna have all the flight control surfaces, and after that we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. In the end part of the video you're gonna see the complete flight. So I keep showing you the flight controls. If you have a failure, as I told you, of the L2 and R2, that affects the L2 and R2 horizontal stabilizer hydraulics system over here, you have to come down here. You will have a malfunction of the auto trim from the auto flight and the flight control computer, so you're gonna have to disconnect your normal to cut off these switches. Then you can use all the alternate if you wish, or the normal pitch string, manual pitch string. As you can see, we have always here nose up and nose down. This way nose down, this way nose up. And the stabilizer trim cutoff, we have the parking brakes here, up and down. You can apply the parking brakes, so you can use afterwards only the manual trim over here, as you can see. And we have the manual trim over here in the side stick. I have mapped in flight to match the yoke of the Boeing 787. So we're gonna see all these things. So you can trim like that. You will see the effect. The horizontal tail of the aircraft will be moving up and down. This is the trim function, the whole surface usually, or just the elevator in some aircraft. So you can climb, descend. You use also the elevator, climb, descend from the side stick. You can use the rudder pedals, left and right, and the ailerons and spoilers and flaperons, left and right again, using the side stick control. So you can climb, you can descend, make turns right and left. I have to show you the rest of the instruments. So I was talking about the navigation display. I will talk to you also about Newton's physics, aeronautical and aerospace engineering, and show you some principles about how the aircraft fly, and some equations we use in flight for the air transfer pilot license. Is identical with the aerospace engineering courses and aircraft design courses. So I'm gonna show you the Bernoulli theory of fluids and Newton's physics. And you can see here, so we have the wings of the aircraft. You can see, you can hold the weight of the aircraft in the surface over the surface area as the aircraft flies. It holds the weight of the aircraft. We have the thrust from the engines that move the aircraft forward. We're gonna see later in the takeoff, when we're gonna taxi the aircraft for takeoff. So we have the longitudinal axis from nose to tail that affects also the roll for making left and right turns, the ailerons and the spoilers. The elevator, we have the lateral axis from wingtip to wingtip for climb and descent, and the vertical axis through the center of gravity, which is the yaw, the rudder pedals, left and right rudder pedals. So also very important, the elevator. As you can see, the tail moving up and down. This makes the aircraft climb if you need to climb or descend. So as it tells you, thrust from the engine. You can see here we have the mean aerodynamic chord position. In the forward wings is the Mach, is where the maximum aerodynamic lift occurs in the forward wings. It's 23% of the Mach of the chord of this aircraft. Is where the maximum aerodynamic lift occurs in the wings, and you need to know that if you're flying aircraft, it's also where the stall will begin in the aircraft in flight for an angle of attack that is different for its aircraft. Maybe weight and airspeed is different also as you're flying faster and slower. So and also altitude of flight and other factors. So you can see also we need to avoid the stall as we fly, because it's gonna make the aircraft fall. Is one of the main reasons. So you can see here we have the airspeed tape, very important. In the primary flight display, as I told you, says you need to have the indicated airspeed always above the red, the yellow and the red indication here that shows you the stall speed. Because the wings are gonna lose the lift and gonna make the aircraft start falling from the air, so we need to avoid that. You can see also monitor always the airspeed, the barometric altitude, other indications. I'm gonna show you in a couple of minutes. So you can see also using the Bernoulli theory of fluids. So we have the vectors, as I told you, the flight control deflections, the airflow deflections as we fly. You can see the bottom surface of the wings is more flat. So also as the aircraft accelerates for takeoff, it takes an angle of attack like this, like 9 degrees for takeoff and for landing. And also because we have the curvature from the flaps, the airflow is moving slower below the wing. So we have higher pressure below the wings, which pressurizes the aircraft weight and wings up into the air. Also you can see the top surface of the wings is more curved, so as the aircraft accelerates for takeoff, there is lower pressure above the wings, which sucks the aircraft up into the air, weight and wings up into the air. So we have differential pressure between the lower wing surface and the top surface as we fly. Usually it depends also. So we're gonna see all that in flight. This is the main principles about flight dynamics. So I'm gonna show you now the rest of the cockpit, and I'm gonna make up a set of the flight management computer using the flight plan. So I'm gonna make a flight plan for the aircraft for this flight. I'm gonna insert all the data of the aircraft for this flight. That includes the empty, that includes the takeoff gross weight. The takeoff gross weight includes the empty weight plus the passenger plus the cargo plus the fuel on board. Where the fuel is stored in the left and the right wing in the center tank. This affects the center of gravity, also the loads from the cargo and the passengers. The flight management computer is going to calculate automatically the center of gravity of the aircraft and the mean aerodynamic chord position. I'll just show you the Mach. And also it will give us the horizontal trim stabilizer, the horizontal tail stabilizer from takeoff, climb, cruise, and approach and landing. Usually for takeoff, using the flaps for takeoff and the runway we're gonna select. It's gonna give us the takeoff speeds, the V1, V8 and V2 automatically also. So as we fly also we burn fuel, so it also affects this also affects the center of gravity of the aircraft as we fly. Is shifted and is recalculated every second from the flight management computer automatically to control position and actuate all the flight controls electrically because it's fly-by-wire aircraft. It has flight control computers, the autopilot, the flight director, the automatic trim, the automatic throttle, and all flight control surfaces are electrically controlled using the flight control computers. You can see over here we have primary flight control computers, and we need them to be in the auto position, as you can see. We have other stuff also to show you. We have flight control surfaces. So here we have heading reference and IRS inertial reference system. This is the air data computer of the aircraft. You can see IRS left switch and heading reference. So whatever you see displayed here in the primary flight display, like the airspeed, the pitot, static, pitot dynamic for the airspeed and the altitude of the aircraft as it climbs and descends, the pitot tubes, the angle of attack using the airflow sensor in the outside skin of the aircraft. Also the pitch attitude, the laser gyroscopes, gyroscopic acceleration and deceleration, GPS receivers, or are included here in the air data computer in the overhead panel. Also the inertial reference position, GPS position, GPS receivers, magnetic North Pole and geographic North Pole, all this stuff. So we have the air data computer for that. So you're gonna see how we're gonna use the Boeing 787-900 for this flight. So I'm gonna show you also, I'm also talking to you about the takeoff gross weight of the aircraft and the left and the right wing, how much fuel we have, 30% right now for this flight of the total fuel we can contain, and 10% in the center tank. So the flight management computer is going to calculate the center of gravity of the aircraft and aerodynamic core position. I'm going to use 15 degrees of flaps and 4.25 degrees of horizontal trim stabilizer, or calculated automatically using the flight management computer. Also, you're going to see other data we need to include. We're going to use the takeoff runway. We are in the Zurich International Airport, runway 14 Lszh, Switzerland. So we're going to use the runway 14 for takeoff and for landing. And we're going to have the runway length, the runway slope, the wind direction and speed, the barometric pressure, the density of the air, and the temperature. We're going to have the takeoff speeds, as I told you, V1, V2, V2. I'm going to insert the seats, the cellular instrument departure, waypoints, and fixes that include horizontal, vertical navigation fixes for the initial climb of the aircraft, also departure. Then we have the climb to the cruise level. We're gonna cruise like 35, 36, 37, 28, 29, 30,000 feet above the sea level. Then we're gonna cross through some waypoints. We have the top of descent. We're gonna start descending back to the elevation of the airport from to like 7,000, 6,000 feet above the sea level. We are 1,430 feet above the sea level right now, the elevation of the airport. So we're gonna have the stars, the southern terminal arrival waypoints and fixes for the terminal arrival and approach and landing of the aircraft into the airport. And the ILS localizer, the instrument landing system, we're gonna tune the ILS localizer, horizontal and vertical navigation, the needle and the glide slope, and the ILS localizer, the crossbars, and we're gonna have this automatically using the flight management computer, and manually we can do using the radio management panel. So I'm gonna start maybe with the flight management computer. I'm gonna create the flight plan right now, and then I'm gonna show you the flight controls. So you can see here we have again another view of the aircraft, the pedestal and the flight management computer. So you're gonna see here so you can see here we have the index, identity, position, performance, takeoff over here, approach and unseat status, navigation data, flight plans, load data, traffic control, load plan, save plan. So we have the identity, Boeing 787-900, position, reference airport, Lszh. So this will give us the nearest GPS coordinate over here. We have performance. So gonna start maybe with the route over here. So gonna insert the departure and arrival, Lszh back to Lszh, departure airport and arrival, destination airport over here. You can see departure and arrival, origin destination. We have runway 14. Then departure arrival, select the seats, the southern instrument departures, and the runway. We can use runway 10, runway 16, 2832. We're gonna use runway 14. Trans Zui to Alpha, departure arrivals, and then arrivals. We can use any arrival 16, 28, 34. I'm gonna use Lszh localizer, runway 14. Trans Amity, trans next page here. We can use any trans. Stars. I'm gonna have the stars over here, the starter terminal, arrival waypoints and fixes, as I was telling you. So we have the stars, the Negria. We have the legs here almost. The flight plan is almost active now. You can see the first, second, third, fourth, fifth leg. Then as we climb the cruise level, then we have a discontinuity here. We need to cancel. Then we have the descent. Over here, approach and landing to the runway 14. The airspeeds as we fly, and the altitudes and the direction, the heading we need to change each time. So we need to activate the flight plan. We have the zero fuel weight over here. You can see 322.7 thousand pounds plus the fuel on board 35,300, gross weight 358,000 pounds. So we insert the fuel, the reserve fuel, the cruising altitude 25,300 feet for this flight, and the cost index. We can fly higher or lower if we like. Minimum fuel temperature over here as we fly is gonna freeze the fuel minus 37 degrees. Cruise altitude, takeoff zero fuel plus fuel, takeoff gross weight. Cruising center of gravity 28%. Over here you can see cruise center of gravity. So we activate, press the execute button. Down here you will see here we turn the legs, turn the execute on. It will give us the purple color instantly. So now we have an active flight plan. You can see displayed in the navigation display. So we have the legs here we need to fly through. Next page, you can see the first one, 136 degrees, 135, 2 nautical miles, 250 knots, 1900 alpha. Then Zui after 3 more waypoints. Zui 6 nautical miles, 302 knots, 6000 alpha. Next page, Negria 26 nautical miles, heading 071. We're gonna make left, then we're gonna make a right turn 076, and flight 302 knots at flight level 22,100. Then we're gonna start the descent. Matif 12 nautical miles, 320, 11,800. Amiki 190, 10,400. Zui 187,000 alpha. ZH 701, 186,000 alpha. Next page, so you can see here TRA 185,000 alpha, CI 184,000 alpha, Osnem 170 knots, 4,000, and then runway 14 140 knots, 1,450 feet. So we have the flaps for takeoff 15 degrees. We're gonna use we have by default 5 degrees, and we're gonna use 15. Center of gravity is gonna be given automatically 28% with 23% with 4.25 degrees horizontal trim stabilizer. You can see the takeoff speeds V1, V8, and V2 over here. So we have a few more things to see. Route, departure, arrival, alternate, VNAV, progress, FMC communications, hold. You can hold here, select a waypoint as you fly, and hold. Fix, insert a fix, navigation, radio. So these are all the functions that we have right now. So I'm gonna show you the flight controls of the Boeing 787 in a couple of minutes. So you will see also these functions of the flight controls. Then we're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. So you're gonna see the flight controls of the Boeing 787 here. So we have almost everything ready. I'm gonna start showing you, just show you a little bit so you're gonna see more detail. Now you can see the elevator we can use for climb, descent, make turns to the left, to the right, use also the rudder pedals. We can use either elevator control wheel or rudder pedals. So you can see here the captain and the first officer are interconnected and move together in flight. Unless we have a failure, and unlike in the Airbus we have the side sticker priority. You can see also the outside view. I'm gonna show you the flight controls also from the outside view, how to use them. Horizontal trim stabilizer, also thrust levers. I'm gonna show you now also this view of the flight controls. So you're gonna see here we can climb, we can descend. We can climb, descend, make turns to the left and make turns to the right. We have the rudder pedals, we have the horizontal trim stabilizer over here, up in these switches. So you can see side stick deflection is proportional to the yoke deflection over here. You can see also the thrust levers here. So hope you like the view of the side stick I use to control the Boeing 787 flight controls. So we have also, as I told you, the outside view, couple of seconds. So you can see we can climb again, descend, make turns left and right, ailerons and spoilers like this. So this is all the flight controls. Also with the speed brakes are retracted, you can see again ailerons to spoilers, speed extended, speed brakes. So this is all for the flight controls tonight. Hope you like it. I'm gonna show you the rest of the systems of the Boeing 787. The displays, what we show you on the autopilot flight director system panel. The thrust levers, the indications of the thrust levers in the engine's indications, and I'm gonna make an engine start demonstration. As I told you, the overhead panel, we have to display some things. So you can see here, we have also the flight plan created. I forgot to mention, using over here the flight management computer, all the waypoints we have here, everything is stored. You can see from takeoff from this runway we're gonna climb, then cruise through. Over here you cannot see it, have to increase the range, then descend, approach and landing, this purple line. So you can see the stars, TRA C1, CI14, OSNM, the terrain 3000 feet, maximum 1600 for this range. The climb over here, the rate of climb, and the slope we can see, the airspeed selected, and the altitude selected from the autopilot flight director system panel, the airspeed indicated and the altitude, barometric altitude. Also we have the flight plan here in the HSI, the decorated display, first intercept after takeoff. So we have the same airspeed and altitude and heading over here, like on vertical rate of climb, descent, auto throttle left and right, autopilot engage, disengage. So you're gonna see all the functions of the autopilot, also the thrust levers. You can see a few things. We have the fuel control, left and right switch. You can turn off and on the engine fuel flow, left and right engine fuel control, fire extinguisher, left and right engine, transporter, rudder trim, radio and communication panel over here, the mouse pad here to control all the screens. You can see I told you about the horizontal trim stabilizer, autopilot disconnect, head-up display, also declutter switch. We have also the barometric pressure setting from the FS panel. Over here, inches of mercury, hectopascals, 29.92 now, minimums. Over here, some warnings, cancel, traffic, weather radar, and terrain on display. So we have also the display of some systems. You can see in the overhead panel, I'll show you later. We have also over here the standby display, landing gear, extended retract, alternate gear. Over here, auto brake, turn to rejected takeoff for takeoff, or 1, 2, 3, 4 for landing. You will see display auto brake or off. We have the flaps position, 30 degrees maximum extended, stabilizer trim position, rudder trim, takeoff gross weight over here, 357.6 thousand pounds, total fuel on board, saturated and temperature of the fuel right now. You can see also we have, as I told you, the flaps display, extend and retract. You can see how many degrees we extend and retract. Right now retract 25, 20, 18, 15 degrees, 10 degrees over here, 5, 1. So we keep retract. You can see the flaps position all the way down. We have the speed brakes also, retract and extend, the thrust lever. So you'll see the flaps over here right now are moving in transition. You can see them fully extended, and also the speed brake fully extended. We can have also here a few more things, the indications from the thrust levers. You can see left, right thrust lever, auto throttle, disconnect, takeoff, go around. You can disconnect the auto throttle, the auto thrust without takeoff, go around, and thrust reverse. I will show you also that later in the landing process. So we have the indication of the engines over here. So I show you the flight plan. You can see also the terrain. You can see the runway we are located. If you look up closer, runway, and the indication where is heading the aircraft right now. If you look the taxiway, we have some mountains over here, and the runway we're gonna use for takeoff, displayed from the GPS. And the taxiway, you can see the curve from the taxiway over here. So we have also other indications. Look further away, other aircraft, terrain, also the planner. You can see the flight plan here, display, map centering, the aircraft also displayed. You can change the range here with this cursor, and the plan or map with the other one. You can see how far away we look. We're gonna see all the waypoints we have to fly through. Over here you can see other airports further away, like France here, Germany here. You can see the waypoints, the flight plan, a much better view. You will get more clutter later if I keep change the map view, the range. So we're gonna have the indications now from the engines. I will show you the engines. I will have the General Electric engines, GNX left and right wing installed, turbofan engines. We have one, as I told you, in the left wing, one in the right wing, both symmetrical thrust and redundancy. Each one contains a gearbox with the FADECs. The FADECs are the full authority digital electronic control computers. One solder in the gearbox, dual channel redundancy, one channel phase, the other takes over, controls one channel displays all the engine data used in the upper and lower ACAS, engine casing control system display or multifunction display, like the N1, which is the low speed starter, low pressure compressor, and turbine of the turbofan, which is the engine, the exhaust gas temperature per engine. The N2, which is the high speed starter shaft, the high pressure compressor, and turbine of the turbofan, which is the engine. The fuel flow per inch per 1,000 kilograms or 1,000 pounds, oil pressure, oil temperature, quantity, and the vibration of the N2 stage of the engine. The FADECs also controls the fuel flow, fuel metering unit, engine start, engine shutdown, engine failures, the pressure inside the engine. We have an overpressure and under pressure. You can open the 59 stage of the high pressure compressor outflow valves to increase or decrease the pressure. Pressure control is inside the engine. Also, we need the pressurized air from the 5th and 9th stage of the compressors, and also from the bleeder from the bypass stage of the front fans to supply with pressurized air from the engines, the cabin pressurization system, oxygen regulation, ventilation and air conditioning, wing and engine RDIs, hot air for this, and also other things. We need the hydraulic fluid tanks pressurization. So the flight controls you see here are moving using the fly-by-wire system, are also hydraulically actuated, so you can climb and descend, make turns in the flight. You see the elevator is moving up and down, and the flaps, speed brakes, external retract, rudder. So you can see here in the overhead panel. So you see in the overhead panel over here. So you see here in the overhead panel. I'm gonna show you the APU, the auxiliary power unit. We need to start the engines later. So I'm gonna show you also. We have hydraulic fluid tanks pressurization. You can see the hydraulic fluid tanks, fuel hydraulic tanks primary demand, the engine driving and electric driving. Also have the hydraulic fluid tanks. I'm gonna show you later in the display with a digital, monitor over here. So I'm gonna show you also a couple more things before going for takeoff and making the engine start demonstration. So hydraulic fluid pressurization from the engines, landing gear, external retract, flight controls, flaps, speed brakes, thrust reversers, parking brakes, nose wheel steering. We have the tiller here for the nose wheel. So all flight controls, hydraulic fluid pressurization, also the FAREX, the pressurizer from the engines. Supply these main things. So we have the APU, the auxiliary power unit. We're gonna need to start the engine. It's gonna backflow air from to the engine to start the engine starters. So I'm gonna show you also as we climb and descend the aircraft into higher or lower altitudes. As we climb higher from the sea level all the way up to like 20, 30 or 40,000 feet above the sea level, or 8,000, 9,000, 10,000 meters, 11,000, 12,000 meters above the sea level. As we climb higher and higher, the pressure of the air, the temperature of the air is becoming lower. So the pressure of the air, the density and the oxygen level become less than half than that of the sea level. Also, the temperature of the air becomes freezing, like minus 30, minus 40, minus 50, minus 60 degrees below zero. Also, the aircraft will be flying with an airspeed rate like 2 or 3 times faster than that of the sea level as we climb higher. So we're gonna have a different fuel mixer request every second. It's been adjusted automatically using the FAREX. Also vice versa as we descend. Also the FAREX control the fuel heat exchange sensors. We need to recirculate the fuel from the wing tanks and the center tank during flight to avoid freezing at minus 37 degrees. We have the automatic recirculation of fuel and also lubricant and oils into the engine's components to duct heat from the engine components and heat up the oil. So you're gonna see also these things. Σε πειράζει να κλείσει την πόρτα. So you're gonna see all these things. So I'm gonna make an engine start demonstration. So you're gonna see in the overhead panel we need to start the electrical, the APU. We're going for an engine start demonstration. So you're gonna see here also the autopilot flight director system panel. I show you the indications from the engines, the N1, which is the low speed starters have low pressure compressor and turbine of the turbofan, which is engine, the exhaust gas temperature per engine, the N2, which is the high speed starters have the high pressure compressor and turbine of the turbofan, which is engine left and right, fuel flow per inch per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. So you're gonna see here the outflow air pressurizer from the engines. Open up from auto to manual. Then you're gonna see the outflow valves position, the warnings over here and the indications. So you're gonna see also the outflow valves position here, cabin altitude, rate of climb, descent, differential pressure, outflow valves position, pressurizer. So we have the autopilot here, engage and disengage, switch, auto throttle, left and right, LNAV and VNAV. If we disarm the flight director, we cannot rearm the autopilot. We have to turn the flight director on. We can change the airspeed if we wish. So we're gonna set for takeoff. Disarm, autopilot, engage, disengage, LNAV, VNAV, climb continues, flight level change, auto throttle, climb continues, bank angle in flight, heading guidance. So we're gonna have the heading of the magnetic north pole heading of the runway 14 we're gonna use for takeoff over here. So we're gonna use 136 degrees for takeoff. The vertical rate of climb descent, the altitude set over here 25,000. You can set higher like 30 or 40,000. I'm gonna set 25 and the hundreds also. So we're gonna have also the vertical rate of climb descent, the zeros over here, descend like this, and also climb. We're gonna turn from minus over here the vertical speed to climb. You're gonna see the plus. So we have plus 3,500 feet per minute, everything displayed in the displays over here. So you can see now the airspeed selected and the altitude are gonna be the same like the autopilot, also the indication we need to monitor. So we have a few more things in the overhead panel now to show you the electrical IDG, the great drive generator, left and right engine, 120, 200 volts, 400 Hz frequency, APU is running, battery. This is the electric panel, primary flight control computers at the auto, air data computers, flight control surfaces, towing power, FD door, passenger oxygen over here, window heat, rammer turbine backup hydraulic, and the pumps, left and right engine drive and turn off. You will see the indications here from left and right engine drive and hydraulic pumps back to the on position. You see the fault indication. So we turn back to the auto. We have the wing and engine RDIs over here. You can see on or auto. We have also the windshield, the lighting system and the windshield wipers. So you can see all the systems in the overhead panel. I'm gonna show you here. We have the recorders, the cargo and APU fire, the electronic engine control for the engine, normal mode and auto start, normal and alternate mode control, electronic engine control, fuel jettison, we dump some fuel in flight and lose weight, left and right wing fuel tank, center tank, fuel booster pumps. So this is the fuel system, the crossfeed you can use to feed either engine with either pump or either tank, or if you have a fuel imbalance. So we have also pressurizer from the left and right engine, air conditioning, oxygen regulation, the packs, and cabin pressurization. Manual, we use the outflow valves, climb, descent, and in the auto you have to do nothing, it's everything automatic. So I'm gonna show you the last thing before doing the edge start demonstration. The digital display of the systems here. So you will see the digital display here, systems over here. You can see hydraulic, APU, oxygen, liquid cooling. We have electrics now, left and right IDG, contactors, integrated generator, APU, main battery and APU battery, voltage 31 volts and the average 120 200 volts alternate current, 400 Hz, hydraulics, where the hydraulic fluid goes, left and right engine driven pumps. Over here you can see electric C1 and C2, left and right wing fuel tank, center tank. How much fuel we have? 11,000, 11,000, 11,000, 33, 34,100 in total. Low and high pressure fuel valves, left and right engine, fed from the center or the left, right wing. The crossfeed valve is off, but if we turn it on, you can feed either wing with either engine with other wing tank or either pump. Also, the APU is fed from left wing using this motor. We have the recirculation for the fuel because the fuel will freeze in flight. We need to heat it up at minus 37 degrees. You can see minimum fuel temperature over here. And this is all for the fuel right now. We have the packs left and right. Packs, engine, pressurizer, oxygen regulation, the doors are closed, the cabin can be pressurized, landing gear, temperature of the brakes and pressure of the tires, flight control. You can see the flight controls movement. Last thing we need to do here in this small checklist before going into flight. You can see all the flight control surfaces, the tail, for instance, the ailerons and the spoilers, and the elevator trim position. So we have more things, systems, maintenance over here, circuit breaker systems again, everything in digital format. So we have the checklist here. Last thing to do, what to do before before takeoff, after takeoff, approach and landing. So we go back, navigation display. We need to turn off both engines. You will see both engines in the off, the fuel control like this. So we turn off both engines and we're gonna restart them very quickly. As you can see, the indication is going to amber like this. So you can see the aircraft, the engines are slowing down. We're gonna start the auto start system very quickly. Gonna supply automatically with pressurizer from the APU. You can see the reconfiguration from other switches. So now it's pressurized from the engines, left and right engine with pressurizer. As you can see, you can hear the roar from the engines pressurizer right now. So above 20% over here we can start the engine starter. So we go for an auto start right now. Fuel control, left and right like this. You can see the auto start is kicking in. We have the indications over here, auto start on, left and right engine. We now have all the fuel system and now the pumps. So auto starting is increasing above 45%. You can see the systems are turning on from the warnings. So auto start right now 56%. We need a couple more seconds and the engines, both engines are running. As you can see, left and right engine. So we use flaps for takeoff, 15 degrees like this. Gonna have also the view for takeoff, and we're gonna taxi now for takeoff. So we are ready. Advance the thrust levers, parking brakes off. And we have 20 more minutes for this video to end. Thrust levers at idle. Here's the tiller. So we align here using the rudder pedals. Advance the thrust levers over here, as you can see, to maximum takeoff thrust, and we have the takeoff roll now. So we align with the rudder pedals like this. Use the rudder to center line 100 knots. V1, we rotate. So we pitch up like 9 degrees for the climb, for the takeoff rotation. We have maximum takeoff thrust, picks up a little bit, string. So we have the positive rate of climb, landing gear up, retracted. So keep climbing. So keep climbing. So you can see here all the indications. You can see the airspeed 177 knots. The stall speed here, we climbed through 4,900, 5,000 feet with 5,000 feet per minute. And we have the terrain around us with green, the terrain below us, and the angle that we have to climb. You can see how far above we are from the terrain, like 4,000 feet above the green line is the terrain below us. So if we look a little bit further away, you will see also terrain indicated with red, green and yellow, also the indication from the engine, so you can see the terrain, the mountains that we have in front. So we have a beautiful view here as we depart the airport, the Switzerland, the lakes over here, the Swiss Alps, and we keep climbing. So we keep climbing. As you can see, we have maximum takeoff thrust. We are climbing over here. So we have a beautiful view as we climb from the aircraft and Zurich over here, the night sky. So you can see the Boeing 787. Also the Galaxy. So we need another 15 minutes for the flight to complete. Keep climbing. You can see the waypoints we have to cross through the flight plan here. We have the LNAV on. You can see better view of the flight plan here on this side. This is a nice view of the cockpit as we take off, after takeoff also. Maybe use a little bit less locations here. Nearest range over here. So we have to cross through this waypoint, the Zui. We have the intercept still here, and we're gonna have the Negria. So we need to make a turn over here, as you can see. So you have a beautiful view of the Switzerland, the Swiss Alps over here, and the lakes we're gonna be flying through very close. Also the Boeing 787 aircraft. So we need to be overflying out here. We can see we can fly with the hands off without the autopilot connected. The aircraft keeps flying the way it's trimmed and has the engine's thrust setting. So it has the speeds added right now. You can see here in the primary flight display also. So we need another 12 more minutes for this flight to complete. So maybe keep climbing a bit higher. 20,500, and we're gonna make a turn right now back to the airport. Overflying very close to the lake here, as you can see. The Germany, my homeland, the Bayern Munich over here, and the France on this side. So we have a beautiful view here of the lake. And we have another 11 minutes left for this flight. Need to use a little bit right rudder to make a steeper turn. So we're gonna be having also the handrails in a couple of minutes displayed over here. So we need to turn to this direction over here, follow the flight plan. So here we are about 2023, almost 1000 above sea level. We have to follow this flight plan here and retract some flaps over here. Increase also the airspeed. I'm gonna have the stall speed now. The indication, we need to avoid the stall here of the aircraft. Maybe retract, extend some flaps. You can see the indications from the engines also. The waypoints we have to cross through, and we are almost 25,000 feet right now. 35,000, and we have the handrails already from the exhaust of the engine over here. We have the view. We are leveling off over here, as you can see, flying with my own flight controls. We have the Germany, Bayern Munich over here, the France, the Galaxy, very beautiful views. Boeing 787. So you can see how high we are flying right now, almost 38,000. So 25,800, excuse me. So we're gonna start the descent in a couple of minutes. And we have 8 more minutes left for this flight. Keep having the chemtrails here. Beautiful view. You can see how fast we're gonna be flying. So we're gonna start the descent right now of the aircraft. We need to pitch down the aircraft a little bit fast, a little bit more to the idle to initiate the descent. We need to trim the aircraft down and follow the flight plan here. So you see how beautiful views we have from the aircraft, and we have 7 more minutes for the flight to reach the airport, make a more steep descent. Use idle thrust for this. And we need to cross through some waypoints, as you can see, as we are descending. So this is the view as we descend from the cockpit. And we have 6 more minutes left for this flight. 18,000 feet, as you can see. The airspeed right now that we have reached. We need to start the turn for the approach and landing. Descending, and we have 6 more minutes. So we're gonna be descent right now. For the approach, is a little bit left rudder. We're gonna make a nice night approach and landing, and we have 5 more minutes, pretty much time for the approach. Follow the waypoints here, the terminal approach waypoints and fixes. You can see also here in the flight plan display. Keep descending over here. And we have 5 more minutes left. Use a little bit left rudder also to align. Descend a little bit steeper, as you can see. We're gonna have to fly through the river, and we have 4 more minutes for the approach and landing. We're gonna use some flaps also for approach. So we're gonna be aligned with these lines over here in the Lszh localizer. As you can see, we have the runway inside over here. So you can see we're gonna be having this nicer view for landing over here, the Boeing aircraft. So we are approaching, we have a little bit side wing, we need to add some thrust, add some flaps also, like 35 or 30 degrees, and add some thrust. You can see we have to be aligned with some side wind. Side wind will make a little bit more tricky the approach. We need to use all flight controls, add some airspeed also whenever is needed, and keep the altitude. Pitch trim up a little bit. You can see the Lszh localizer here. We have all the indications from the Lszh localizer as we are approaching airspeed, altitude, radio altitude above the ground, how many feet above the ground we are. So we need also a little bit maybe less thrust, more and less thrust from time to time. So we are almost aligned. Is a little bit to the left, a little bit more engine power, more engine thrust actually. Right pedal right now to align with the center line. A little bit lower now. Increase the rate of descent now. Align with the center line. And we're gonna be having the flare in a couple of seconds. So here is the flare of the aircraft. Flare and touchdown, beautiful touchdown. Parking brakes on, as you can see. Parking brakes on. Idle thrust and thrust reverse also. So we made a very successful, very beautiful flight. And we are slowing down to the runway, align with a little bit rudder also. So you can see we just over here, just landed in the runway. We have plenty of runway more to extend the slowdown of the aircraft if we need. So we have over here, you can see the nose wheel of the aircraft is pretty much safe. There is no breakage of any part of the aircraft in the landing gear, as you can see. In the wheels forward, in the nose wheel, as you can see, all the landing gear behind it. So you can see all the parts of the aircraft are standing up the way it should be. The wheels here, the tires, also over here, the nose wheel. So is everything pretty much safe for another flight over here, as you can see. So we have to disarm the thrust reverse.